Okay, this question is a calculus question and it's got to do with the functions. So let's have a look. They give us a cubic equation. They say the equation is y equals x cubed plus ax squared plus cx plus d. Let me just move everything here for you guys. There we go. That's it. Now you can see the full thing at home. Okay, folks, there we go. So they've given us this curve, but what I find interesting here is there's 3 variables in that equation that they're going to ask us to solve. But they're only giving us 2 bits of information. They're giving us an x-intercept and they're giving us a y-intercept. And Pilontle, that is the trick. They want you to remember what you learned at school and say, how? There is D, so D is 20. Yay, I can tick D, I've got it. D is usually the y-intercept. Okay, so no, we're not going to fall into that trap. We are going to ignore that the y-intercept for the moment, and we are going to work with the coordinates of the roots, even though we don't have both. Look at how clever this is. If I ignore this for now, and I say, you know what? I have got more information. At this point, I have a root of multiplicity 2. What does that mean? That means at the x-intercept, it's also a turning point because the graph is touching the x-axis. So we say it is a root, but it is of multiplicity 2. Now that 2 is represented in the power of the factor. So let's start and say y is equal to, we've got the leading term. The leading term is given here. There's an invisible 1. So we don't need to put an a here. Usually we would say a, x minus root 1, and in this case x minus root 2 all squared, or if we call it a if we want to, or p or q. But in this case, a is given as 1. Now I'm doing this, folks, so that you can remember. You cannot just assume that a is 1. You've got to look at the information, look at it carefully, and then go to the diagram and put the values in. So I'm going to remove that a. I don't need it. Okay, so let's continue. Therefore, what do we see? We see that y is equal to x minus 5. Again, the double negative appears. So that's x plus 5. And let's just introduce that root as an a. So x minus a all squared. Now I need one more bit of information. Can you see, folks, we've reduced the need to solve 3 variables to 2 variables. Once we've got the 2 variables, because we're using a different form of the equation. So once we've got the 2 variables, we just multiply it out, and there the 3 variables appear. This is magic. I love it. I call it mathemagics. Okay, so the x value, this is a point, and we're going to use it as the point 0 and 20. So the y value is 20. The x values are 0. So again, I'm left with a 5. And I'm left with minus a, which is squared. So what does that tell me? That tells me that a squared is 20 divided by 5, which is 4. And therefore a, now be careful, look at where a is. It's on the positive side. So usually I would say plus or minus 2. I'm only going to work with a positive 2 because a is positive where it's located on my graph. Now I go back. Remember, there was a b, a b, and a c variable. We didn't use that form. That's called the standard form. We used the root form of the cubic to get to the standard form. So we put the 2 in there. And finally, we have y is equal to x plus 5, x minus 2 all squared. And now it's just a matter, you've done most of the work. It's a matter of cleaning that up. So x plus 5. That is x squared minus 4x plus 4. I'm going to work a bit quicker here. I want to finish this question. So that's x cubed plus 5x squared minus 4x squared over there minus 20x plus 4x, and then a final plus 20. Now at this point you can check yourself. The y-intercept is 20, and when you multiply this out you get the 20, so you're guaranteed your answer is going to be right. All that's left now is to add the like terms, so let's quickly do that. X cubed plus x squared, here we have minus 16x plus 20. So the question was asking us to find A, B, C, and D. Now answer their question, folks. Finally, A is 1, B is minus 16, and C is indeed 20. Okay, let me just see if I've used those same variables. Yes, A, C, and D. Okay, A, C, and D I wrote in the equation. So let me just change this to a C and to a D. Then it lines up with what I've got here. So C is that, and D is definitely 20. So that was quite nice. A few marks there, 4 or 5 marks that we earned in that portion. Now the next question is asking us to find the coordinates of, I think it's R, and P. Now at R there's a turning point. At P there's a turning point. Okay, so we already have the coordinates of one of the turning points, and let's cash in on that. Okay, so for the turning points, the second part, dy dx is 0 at the turning points at point R and point P. At the turning point, the gradient of the tangent to the curve is 0. That's why we use the derivative equal to 0. Now we've got the equation here. So the derivative will be 3x squared. I keep on moving off the screen there with you guys. There we go. So the derivative there is x squared plus 3x squared plus 2x minus 16, which is 0. A quick factorization. Now here I can cheat. I know the one factor is going to be x minus 2 that I have there, because it's not only a root, it is a turning point. It's a root of multiplicity 2. Those type of roots are also, at the same time as being a root, it's also a turning point. So what's left? There's a 3x left there. There's an 8 that must multiply with 2 to give me minus 16, a positive on the inside. So here we go. The one point is at 2, and this is the x coordinate of point P, or then the x coordinate of the other turning point, which is this point over here. It's point R on our diagram. That x coordinate, and it's an ugly one, is minus 8 over 3. Now folks, they didn't just ask us for the x coordinates, they asked us for the coordinates of the turning point. So we need the y coordinate, okay? Now it's going to be quite tricky with this ugly coordinate here for x. That x has to go into that equation. So the y value here for P we know is 0, because that is the turning point and the root. For the y value of R, we need to take this x, this value here, into the x's in our equation. Use it very carefully. A nice way to do that is, let me show you a nice trick here, is, oopsie, I've now lost my calculator, is to say minus 8 divided by 3, and that there is your answer. So answer cubed, okay, get out of the power, plus x squared, so plus answer squared, then minus 16 times answer, which is the answer. This is now stored in the answer, plus 20. Okay, and you can see it's an ugly number, 1372 over 27. 1372 over 27. Okay, and that is the y coordinate for point R. You don't have to take it down to decimal form. You can leave it like that. They did not ask for it in the question to be decimal form. If they had said correct to 2 decimals, then you've got to use your calculator and you've got to calculate that in decimal form. By the way, in decimal form, it is 50,8. Okay. Now, the next question, this is what I like. They ask us about this question in question number 3. Mpilontle, this is a very good question, and I love it for the next 2 components of this question. Okay, and the first question is saying, it's asking us about the point 0.2. It says discuss the concavity of the curve at that point. Now that point happens to be the y-intercept. They want us to discuss the concavity at the y-intercept. And a lot of kids have a problem with this. So let me spend some time just quickly teaching it to you. If the curve is doing that and is doing that, this here means the concavity, it's downward. If you look at the tangents you are drawing to the curve, their gradients are becoming smaller and smaller. So here, the second derivative takes on a particular value. The second derivative is negative. Then it's concave downwards. Here, the second derivative with respect to an x value is positive. Now, we can see that because if we draw tangents to the curve, even though they're negative, they're starting to become positives. So we are looking, so this is, let me just write it here, concave upwards. Now, folks, this is how you're going to remember it. And I hate teaching recipes, but so many kids battle with this idea and battle to remember this. So if you're scared of forgetting this in an exam, look at this. There's an N in downwards. That is an N. There's in upwards, there's a U. There's a U. Okay, so if it's concave upwards, the diagram has that shape. If it's concave downwards, the N, the diagram has that shape. How do we find the actual points? We're looking at second derivatives here. Okay, so I'm not going to apply that here. I'm going to look at where's the point of inflection, because as the graph goes through the point of inflection, its concavity changes. Folks, there's 2 ways to do that. To find the point of inflection, I'm going to put this in yellow again. To find the point of inflection for a cubic curve, there's 2 ways. You can find the second derivative, make it equal to 0, and solve it, and that gives you the x value. Okay, for the y value, just plug it back into the function. Or you can do, alternatively, you can just apply x is minus b over 3a. I like this one because you guys are so used to doing that in grade 11, you can do that with your eyes closed. Okay, now our b value is the c value in this equation over here. Because remember, b is usually the coefficient. This is a, that is b. So in usual terms, this will be ax cubed plus bx squared plus cx plus d. So I'm looking at the coefficient of the x squared term, which in this case was the value of a. Okay, and the value of a was 1. So this becomes minus 1 over 3 times a. Now that a is the a that's right here at the beginning, and that a is 1. Okay? So you have x is minus a third. If you want to, you can go and work with a second derivative. I'm just going to do it way up there so you can see it's the same thing. You get 6x plus 2, which is 0, and that if you differentiate this again, then that solves to a beautiful minus a third. So whichever one, folks, you feel comfortable with, you use. What does this answer mean? Let's go to the graph. It means that at x equal to minus a third, that is where the point the function has its point of inflection. So what is the y-intercept part of? It's part of the U. It's part of the U because it lies to the right of the inflection point. Therefore, at 0, 20, the function is concave upwards. Now, Mpilontle, I hope that helped you to interpret that question. Remember the N and the U. N means downwards. U means concave upwards. I've got 3 minutes to discuss the last question. I want to quickly discuss it with you. So, folks, I'm going to go quickly through it. It's a nice question. It says they want us to sketch this graph where G of 3 and G prime 3 is 0. Now, again, we've got what we just had in this question. So that's a root plus it's a turning point. Okay? It's a root of multiplicity 2. Then they tell us G of 0, the y-intercept, is 27. So we've got the y-intercept, we've got a root of multiplicity 2, meaning it's a root and a turning point. And they tell us that G prime prime x is positive if x is smaller than 3, and G double prime x is negative if x is bigger than 3. So what does that mean? It means at the root or at the turning point, the concavity changes. It changes from concave downwards to concave upwards. From the negative side, from concave upwards rather, to concave downwards. And then it crosses the curve. So if they ask us to draw this diagram here, we know this is a double root. We know that that's our y-intercept. Our y-intercept is at 27, so the function is going to come down. It's working, it's concave, up. It goes through the point 3 and then continues concave downwards, and that's the function. A good 4 marks for that diagram. You had to interpret it for what it was. They gave you the double root or the root and the turning point that coincides. So that is a root with a root of multiplicity 2. Okay? Then also, as the graph passed through that root, Mpilontle, it changed its concavity from concave upwards to concave downwards. And then they said it cuts the y-axis at 27. So we had that, we had this point, and we had the concavity. This here is concave upwards. You can see it's on its way to form a U, and here it's concave downwards. It's part of an N type of graph.